Hello and welcome to our lesson on the fundamental counting principle. What the fundamental counting principle and what we're going to start with in a second here is going to allow us to do is to show and find all of the different possibilities that are out there, the total number of possibilities that are out there in a certain situation where you're choosing between multiple things. For instance, you go to a restaurant and there's 5 items that are on the appetizer menu. There's 10 different entrees to choose from, 3 different desserts to choose from. What you could do with the tree diagram and or the counting principle is determine the total number of options when you're choosing. Okay, so a tree diagram in this case is going to be helpful in actually illustrating or showing us what all the total options are going to be. So this is going to be helpful in showing or illustrating the number of ways in which a series of successive events can occur, like you choose your appetizer, you choose your entree, you choose your dessert. Okay? Each branch of the tree diagram is going to show the options for any particular choice. So you're going to have one branch for your appetizers, another set of branches for your entrees, and then another set of branches for your desserts. And the total number of options in your scenario you're going to be able to count along the bottom of your tree diagram. Okay, now the more choices you have, obviously the bigger a tree is going to be, and that's where the counting principle is going to help us. Okay, so let's start with the tree diagrams though. Suppose you're picking your outfit for tomorrow, and you can choose between blue or black jeans to wear with your white, red, or blue shirt. So we're going to try to make a tree diagram to show how many outfits are possible, right? How many outfits are possible, show them with a tree diagram. So we've got 2 levels to our tree diagram. Okay, one level is going to be for the first choice of either blue or black jeans, and then the second level is going to be for the second thing we have to choose, which is our shirt, and that could be red, white, or blue. So 2 levels of this tree diagram. So level 1, our first set of branches will be we could choose between blue jeans or we could choose between black jeans. Okay, now let's say we choose the blue jeans. Here's where the second level comes in. We could choose with our blue jeans to wear a white shirt. We could choose to wear with the blue jeans the red shirt, or we could choose to wear with the blue jeans the blue shirt. Right? Or we could have chosen to wear the black jeans and then each of those 3 shirts as well. So we have black jeans with a white shirt, or black jeans with a red shirt, or black jeans with a blue shirt. Okay, so it looks like our shirts are duplicated, but it's because each of those options is available with each of the pairs of pants. But again, we have 2 levels. So we have level 1 here for our first choice, which was blue or black jeans. And then we have another level here, which is for our second choice, which was the shirt, red, white, or blue. Now, if we want to know the total number of outfits that are possible, we're going to count along the bottom of the tree diagram. So we could have had, in total, or let's see, let's go all options, let's say that here. All options would have been to wear blue with white, right? Let's just say blue with white, or blue with red, or blue with blue, okay? Or we could have had from the next block here, black with white, or black with red, or black with blue, okay? So that's a total of 6 different options, right? We had option 1 was here, option 2 was here, option 3 was here, 4 here, 5 here, and 6 here. So all the options here are 6 total. So that it would be 6 total outfits. Okay, so 6 total outfits all shown in that tree diagram. Not so bad, hopefully. Let's try this again. Let's see. The lunch specials at Betty's Bistro offer an entree, a side, and a drink. So we're going to have 3 tiers this time. It says for the entree, you can choose a soup or sandwich, and then you can choose to have chips, fruit, or French roll for the side, and then finally you can choose to have a bottled water or a soft drink for your beverage. So we're tasked with drawing a tree diagram to show the total number of lunch combinations that are possible. So 3 tiers this time. First, we're going to have to choose our entree. So soup or sandwich. Okay, so we can choose a soup or we can choose a sandwich. All right, next level. After we've chosen our soup or sandwich, we can choose to have chips, fruit, or a French roll. So it could be that I choose soup with chips, or soup with a side of fruit, or soup with a French roll. Okay, or I could have had my sandwich with chips, my sandwich with fruit, or my sandwich with my French roll. Okay, so there's my second tier. Again, tier 1 was choose your soup or sandwich. Tier 2 was choose your, after you've chosen your soup or sandwich, choose your side. And now we're going to go with the third tier. Okay, the third tier is choose to have bottled water or a soft drink for your beverage. So I could have chosen a soup with chips, and then from there I choose water or soda. Or I could have had soup with fruit, and then I could have chosen water or soda. Or it could have been soup and a roll, and then water or soda. Right? And the same thing on this side. It could have been a sandwich, and then chips, and then water or soda. Or it could have been a sandwich with fruit, and then water or soda. Or it could have been a sandwich with a roll, and then water or soda. So that third tier strings all the way across here. So what are all of my options? Okay, all options. All the options. First, I could have had, let's see, soup with chips and a water. So soup, chips, water. Or I could have had soup, chips, soda. Soup, chips, soda. Okay, and these are just abbreviations to make our life a little easier here, right? Or we could have had soup, fruit, water, or soup, fruit, soda. So soup, fruit, water, soup, fruit, soda. Or I could have had soup, roll, water, soup, roll, soda. Soup, roll, water, soup, roll, soda. Okay, and then there's the next side over here, where I could have had a sandwich, chips, water, or a sandwich, chips, soda. Sandwich, chips, sandwich, chips, water, or sandwich, chips, soda, or sandwich, fruit, water, sandwich, fruit, soda, sandwich, fruit, water, sandwich, fruit, soda, and then lastly, sandwich, roll, water, sandwich, roll, soda. Sandwich, roll, water, sandwich, roll, soda. And now we count all of those up. 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6 at the bottom of the tree. And then 5, 6, 7, 8. Wait, 6, sorry. I can't count. 6 over there. 7, 8, 9, 10, 11, 12. So 6 from the one side, 6 from the other. That's 12 options total. 12 lunch combos, combinations it could have been chosen from. Okay, that was a big mess. Hopefully you spaced that out a little better for yourself. Okay, so again, the more options you have, the more complicated the tree branch is going to get. But there is a faster way to calculate the total number of possibilities, which is going to help us not only in these situations, but as we progress in our unit, which is ultimately going to be looking at probability. The counting principle is where this comes in. It offers us a formula. This gives us, let me just change color to a formula to determine the total number of options we can count from the bottom of our tree diagram. And it states that the number of ways in which a series of successive events can be found can be found by multiplying. Just multiply the number of ways in which each of those things can occur. So let's talk about this shortcut, this formula that we can use and apply it to problem or example 1. So example 1, for our first option, we had to choose blue or black jeans. That was 2 total options. Second thing we were choosing was a shirt, and there we had 3 options. Okay, what the counting principle says, if we just multiply the number of options in the first choice and the number of options in the second choice, we'll get the total number of options. And what is 2 times 3? It's the same 6 that we found at the bottom of our tree diagram. Okay, so get rid of this, go back here, applying this to problem. Oh man, keep deleting stuff on accident. Sorry. Okay, back down here, applying to example 1. So we had to choose a shirt, or no, we had to choose pants. Pants was 2 options. And then we had to choose a shirt, which was 3 options. Okay, so the counting principle says just multiply the number of options here by the number of options here to get 6 total combinations. Okay, in that case, the combinations were outfits. Okay, and then we could have done the same thing with example 2. First, we were choosing an entree. And for the entree, we had 2 options. And then we were choosing a side. And for the side, it could have been chips, roll, or fruit. That was 3 options. And then we were choosing a beverage, a drink. And we had 2 options there. And so the counting principle says we can multiply the 2 times the 3 times the 2. 2 times 3 would be 6 times 2 would be 12. And we would get the 12 total combos in that situation. And that's exactly what the tree diagram showed us. Now, if we want to see exactly what each of those combinations is, that's what the tree diagram is really helpful for. It shows us, soda, chips, water, or soda, fruit, sandwich, chips, whatever. It shows us all those options, okay? So if we want to actually illustrate what each of the 12 outcomes are, then the tree diagram is really helpful for that. If we just need to know that there are 12 outcomes or 12 total combos, the counting principle is a quicker way to get to that number, okay? So let's practice using our counting principle for a few more examples. So a restaurant's offering 10 appetizers and 15 main courses. In how many ways can you order a 2-course meal? So how many total combinations are there possible? Well, the counting principle says we're going to take our 10 options here and multiply by the 15 options here. So 10 times 15 is 150 different combinations. Different, in this case, 2-course meals. Right? And I know you're only choosing 2 things there, but imagine if you had to make a tree diagram to show all 150 of those. That's a lot of branches, okay? If you're feeling like this is a not so bad of a concept and you want to try the next problem, feel free to pause the video. Otherwise, let's see what we got going on here. This is the semester that you will take your required psychology and social science courses. Because you decided to register early, there are 15 sections of psychology from which you can choose. Furthermore, there are 9 sections of social science that are available at times that do not conflict with those for psychology. So in how many ways can you create your 2-course schedule to satisfy your requirement? So again, accounting principle says we can just multiply. Multiply the 15 options for psychology by the 9 options for social science, and 15 times 9 is going to be 135. So there are 135 different 2-course schedules that you could have created, which is just bananas, right? When you start thinking about how many options you have sometimes, okay? All right, let's try another one. Number 4 says a pizza can be ordered with 2 choices of size. So you order your pizza, you choose your size, medium or large. And then you can get 3 choices of crust. So another option after you've chosen the size is to get a thin, thick, or regular crust. And then you have 5 choices of toppings. So 5 choices of toppings: ground beef, sausage, pepperoni, bacon, or mushrooms. So based on these options, this was 5 and 3 and 2. How many different 1-topping pizzas could you order? So you choose 1 size, you choose 1 crust, you choose 1 topping. So it says 2 choices for crust, 2 choices for size, 3 choices for crust, and then 5 choices for your 1 topping. 2 times 3 would be 6, and 6 times 5 would be 30 different 1-topping pizzas. And there it is. Again, it wouldn't be difficult to draw out the tree diagram, but it would definitely be a larger diagram, okay? Alright, car manufacturers are now experimenting with lightweight three-wheel cars designed for one person and considered ideal for city driving. Are you intrigued? Suppose you could order such a car with a choice of 9 possible colors. So first you're going to choose from the 9 possible colors, and then you can go with or without air conditioning. And then you can choose to get, let's see, electric or gas powered. And then you can go with or without your onboard computer. So in how many ways can this car be ordered with regard to those options? So first we had 9 colors to choose from. And then with or without air conditioning, that's 2 choices. And then electric or gas powered, that's 2 choices. And then with or without your onboard computer, that's 2 choices. So how many choices do we have altogether here? 9 times 2 times 2 times 2 is going to be 72 options. So 72 ways to order the car. The options for the car. Okay, so this isn't so bad as long as you can multiply. Hopefully this is something you can handle. Alright, let's look at the next example. It says telephone numbers in the United States begin with a 3-digit area code followed by 7-digit local telephone numbers. Area codes and local telephone numbers cannot begin with a 0 or a 1. How many different telephone numbers are possible? So think about your options, right? Numbers could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. You could put anything else in a spot, right? That's 10 numbers that, or digits that we could be looking at. So 10 digits, okay? Now when we're creating a telephone number in the United States, it says there's a 3-digit area code and then a 7-digit phone number. So we have an area code. Too many colors going on here. So an area code that has 1, 2, 3 digits, and then we have a phone number that has 1, 2, 3, 4, 5, 6, 7 digits. Okay, so we have 10 technical digits in our United States phone number. Now it says that area codes and local phone numbers can't begin with a 0 or a 1. So in this first spot, and here in the area code, and this first spot here in the telephone number, we can't put a 0 or a 1. So I can't put these 2, but I can put any of the other 8 digits in that spot. So I have 8 different numbers that could go here, and I have 8 different numbers that can go there in that first spot. But all the other digits, doesn't say there's a restriction on them, which means all 10 of the options, right? All 10 of these options can go in the rest of the spots. So I can put any number from 0 to 9 here, all 10 options here, all 10 options here, and so on. Every other spot in our telephone number can have all 10 options. So if I want to find the total number of phone numbers that are possible, I have to multiply all of the options for all of those spots. So we have to multiply. Let me change that color again. If I multiply all these, boom, 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 then we get something I'm going to put into the calculator. Let's see. 8 times 10 times 10 times 8, and then 1, 2, 3, 4, 5, 6 more 10s. Now, notice the number here is written kind of strangely. 6.4 times 10 to the 9th, that's technically scientific notation. I'm going to put this up here in a second, but 6.4 times 10 to the 9th means the decimal has to move 9 more places to the right. So right now the decimal is here. 2, 3, 4, 5, 6, 7, 8, 9. This is saying the decimal should be 1, 2, 3, 4, 5, 6, 7, 8, 9 places over. So let me get rid of this. It should be there, which makes our number really huge. Let's see if I put a comma here, comma there now. We're looking at 6,400,000,000 different phone numbers are possible. Now, just to point this out too in your calculator, what you had 8 in the total product, if you didn't want to type that whole thing out, you had 8 in there multiplied by itself twice, and then you had how many 10s in there? Let's see, there were 6, 7, 8 of those. So if you want to put 8 squared and 10 to the 8th, instead of typing out all those 8s and all those 10s, obviously you get to the same answer. But that 6.4 times 10 to the 9th means you need to move the decimal 9 times to the right. So that would be moving the decimal once here and then adding 8 more zeros. So this is 1, 2, 3, 4, 5, 6, 7, 8 zeros. 6,400,000,000 different phone numbers. And that is craziness. Okay? Alright, so sometimes our combinations end up being really large numbers. And this is in the way, so let me try that again. Okay, so last one. Again, if you're feeling confident and you want to try it out, then give it a shot. If not, let's see what we got here. It says you're taking a multiple choice test that has 6 questions. Each of the questions has 4 answers. And how many ways can you answer the questions? So you've got 6 questions, right? 6 questions. Question 1, question 2, question 3, question 4, question 5, question 6, okay? Just to help you organize here, not that you had to write that out, but each of the questions has 4 answer choices. So what I would see happen on a question or a problem like this is people would take the 6 and say, let me multiply by 4, boom, 24. Well, that's not quite what's going on here, right? We have these 6 different questions, and we have 4 choices for question 1, 4 choices for question 2, 4 choices here, 4 choices here, 4 choices for each of those questions. So we're really not multiplying 6 times 4. We're multiplying 4 by itself 6 times. And 6 times 4 is not the same as 4 to the 6th power here. Okay, so be really careful with that. So we want to multiply 4 times 4 times 4 times 4 times 4. Or in the calculator again, this is 4 multiplied by itself 6 times. 4 to the 6th power is 4,096. 4,096 ways in which those questions could be answered. So there could have been 4,096. If you had 4,096 students all take this test, it's possible that all 4,096 of them answered in different ways. Probably not a probable thing, but it's possible. Now, if you would have had, let's say, 5,000 students take this test, then you'd have, 904 of them that would have been duplicates. Okay, so there's that. Counting principle, again, pretty straightforward as long as you can multiply. Just make sure you're careful, and if you're not sure about what exactly you're multiplying, try highlighting out those options, or try like I did in 6 and 7, writing out, a spot for each of the things you're choosing from and how many options you have for each of those choices. Okay? You have some practice that can help you. Make sure you got a good grasp on this, and if you find yourself struggling, as always, feel free to reach out. All right, guys, take care.